Z is a function, so we have given Z is a function of x square plus xy cubed. Z is a function of x and y, and x is a function of u and v. This is a u v square plus w. It's like x is a function of u, v, and w, and y is a function of, again, u, v, and w. U plus v e raised to power w. So you can draw the tree. Z is a function of x and y, and these x, y is a function of u, v, and w. So this is the chain. So u, v, and w. So z is a function of x and y. You can see x and y are the variable of function z, but x has then variable u, v, and w. So I put that over there, and y has variable u, v, and w. Okay. So now we want to write the chain. So they ask you to find the derivative of z with respect to u. So this is the first one. How many ways are there to go to z? If you start from z, how many ways to go to u? So there are two different ways. So you can go along this path, or you can go along this path. You can first go z to x, and then x to u, or you have an option to go z to y, and then y to u. So if I write down these two paths, what I get? I first go from z to x, and then x to z, x to u, and then you add a sign, plus sign, and then I would go from z to y, and then y to u. So these are the only two different ways from going z to u. Okay, we have the formula now. What we need to do is, we need to plug all these derivatives. Now the derivative of z with respect to x. So I'm gonna take my y as a constant and differentiate this equation with respect to x. So if x is the variable, so the derivative of x square is going to be 2x plus derivative of x y cube. Y cube is a constant, it will stay outside of the derivative. Derivative of the x is a 1, so this is going to be a y cube, and that's one parenthesis here. So this is the derivative of z with respect to x. So what is this? This is the derivative of z with respect to x, partial derivative of z with respect to x. Now, next is the derivative of x with respect to u. So here v is a constant. V and w they are both constant. I'm going to differentiate with respect to u. If I differentiate with respect to u, this is going to be v square plus derivative of w cube with respect to u is going to be 0, because w is a constant here. So this close this one. Now, the differentiation of z with respect to y, now x is a constant and y is the variable. So derivative of x square is going to be 0, because x is a constant, plus x is a constant, it will stay outside of the derivatives. Derivative of y cube is a 3y square. So what I will get? I will get 3xy square. This is the derivative of z with respect to y. And then the derivative of y with respect to u is going to be 1 plus v e to the w. They both are constant when I'm taking the derivative of y with respect to u. So this is going to be 0. So this is your answer. But they ask you to compute this value, the partial derivative of z with respect to u, at a specific point, which is 2, 1, 0. What does mean? It means u is 2, v is 1, and w is 0. Okay? If this is the case, what is the x and y? If I plug u is equal to 2 here, and v is equal to 1, and w is equal to 0, what I get? So u is equal to 2, so this is a 2, and this is a 1, this become 2, plus 0 square, that's become 2. And if I plug that number here, u is a 2, v is a 1, and w is 0, this is going to be 2 plus 1, this is going to be 3. Is that okay? Okay, plug all these information, all these u, v, w, x, and y here, and let's see what we get. 2 times x, what is the x? X is a 2, so 2 times 2 is a 4, plus y cube. Y is a 3, 3 cube is 27. What is a v? V is 1, 1 square is a 1, that's easy. That is a 3 times 2, because x is a 2, and y is 3, that's going to be 9. And then you're going to add them up. Anyone want to volunteer calculation? 27 plus is going to be 31. And what is this? 6 times 9. 54? 54. And this is going to be 85? Is that correct? Okay. I will let you, again, you can see that this is just a chain. I write down the chain G to Z. So there are two different ways of going there. So Z to X and X to U and Z to Y and Y to U. And then you just compute the partial derivative carefully. If you do the calculation correctly, you will get the right answer. I will put this one here, and you can check the calculation if everything is okay. Similarly, we can compute the derivative with respect to y. That I'm going to leave it for you, and I will do the next one. So y is going to be again, so you go z with respect to, v. So you go from z to x and x to v, and then you give z from y and y to v. And similarly, you can do for w also. Okay, one more question. This is also related with chain, but this is called implicit differentiation. So number 2. This is implicit relation. Implicit differentiation. The relation we have, so the relation f, x, y, and z we have is x, y, z minus, so there you go, I have one more student here. Math is here. X plus y plus z. So this is the implicit relation. So I need to compute the derivative of z with respect to x. What I could do is basically you can find the z in terms of x and y and then compute the partial derivatives, if it is possible. But I don't think it is possible doing the implicit relations, because from this implicit relation, find a z with respect to x and y is not possible. So we will use the chain rule, and in this case, the chain rule, which is coming from a chain rule actually, the partial derivative of z with respect to x, the formula is negative sign the partial derivative of the implicit relation f with respect to x divided by the partial derivative of the implicit relation with respect to z. So the x variable goes in the denominator and the y variable goes in the denominator. So it goes like this, x goes here and y goes there. And there is a negative sign. Do not forget there is a negative sign. Negative sign is important. Okay, so all we need to do is, we need to plug these informations in this formula. So what is the partial derivative of f with respect to x? How I get the relation? Basically, I move that cosine cos x plus y plus z on one side, and then I have that relation, which is I call the implicit relation. So negative sign is here. What is the derivative of f with respect to x? I'm going to differentiate this partially with respect to x, treating x as a variable and everything else are constant. So this is going to be yz minus the partial derivative of cosine is a sine with a negative sign. So it's going to be x plus y plus z. The derivative of inside is going to be 1. So I use the chain, but it was the derivative of with respect to x is going to be 1. So you don't have to multiply anything. And then it's divided by the partial derivative of this implicit relation with respect to z is going to be xy minus minus plus. This is again going to be sine, and this is going to be x plus y plus z. And that's all. You don't have to simplify this one. Please do not cancel this with that, okay? They can't cancel because there is a plus sign in between there. Okay, any question before we move to the next one? Okay, James.
Why did you say that?
This is the formula. You know, this.
What's large F7?
This is implicit relation. This is the implicit relation which I get from my implicit relation. You know?
Is that a partial F sub x? Is that
Yeah, it's a partial derivative of f with respect to x. This notation f of x is means this. You know, this notation was this. F of x is means partial derivative of capital F with respect to x. If you guys remember. Okay, this